Paper 1, question 2. So we're given a number, 5,940,224, and we're asked to write it in the form of a times by 10 to the power of n. This is sort of scientific notation, standard form, where the a value is between 1 and 10, and this power for n is a natural number. We're asked two significant figures. So the most significant figures are the millions and the hundred thousands. So the first thing to be conscious of is the fact that 5,940,224 to two significant figures is 5,900,000. Okay, why that? Well, I'm looking at the after that 9. I'm cutting it off after 9. They're the most significant digits. The 5 and the 9. After that, it's a 4. Is 4 less than 5? Yes, it is. So I'm rounding it down. Okay, if that had been a 5 or a 6 or so forth, then I would round this up to 6 million. So, as a number, as we understand it, two significant figures, this population is 5,900,000. Now I want to write it in this format, so you just need to appreciate or learn how to do scientific notation. So if you imagine that you were to have the decimal point after the first significant digit, okay, what would we have? We'd have 5.9, so on and so on. What do I times by 10, or by 100, or by 1,000, or by what have you? How many times do I times by 10? Well, if you think about how many decimal places I would move to go from here to here, I'm moving 6 places. So it's 5.9 times 10 to the power of 6. That 10 to the power of 6 is basically saying I'm going to times 5.9 by 10, and then 10 again, and again, and again, and again, and again. Okay, and I would get 5,900,000. That's what happens when we times by 10 to the power of 6. So it's, in a sense, doing the process in reverse, getting this number down to a number that's between 1 and 10. Well, how many 10s, in a sense, are going on there? It's 6 of them times by each other. So 5.9 is your number between 1 and 10, and your little n value is 6, natural number. Part B is asking you to use your answer from Part A to calculate a population growth rate. So they're asking you to use this answer here rather than the actual value. So what's going to happen? We're going to get an answer that's not technically correct, and then we asked to find out the percentage error between the actual answer and, in a sense, the answer, the rough answer that we got in Part B, Part 1. So let's just understand what a population growth rate percentage change. Okay, so percentage change is going to be the change divided by the original multiplied by 100 to turn it into a percentage value. So the first thing to be aware of is what the change is, the actual difference is. Well, that difference is going to be the exact value of 6,453,682, and from that I'm going to be taking away the 5.9 times 10 to the 6, i.e. my 5,900,000. And we're going to divide that by the original estimated amount of 5,900,000. And when we work that through, we end up with 9.38444, but we want it correct 2 decimal places, as asked in the question, and we end up with 9.38%. So the suggestion is that the population has grown by 9.38%. Now, because that we use our answer from part A, that actual answer of the 9.38% is not necessarily correct because we use an incorrect value in our calculations. So then it's asking us to work out what's going on. The second part of question B is not easy to fully understand what they're after. You have to drill down into it. So you've worked out the percentage change in population, but it's an estimate. So, and they're asking you now to tell us what the error in that estimate is. So the first thing you need to do is you need to work out the actual answer. So rather than this, we have to go through the same process again, but with the actual numbers, not with that 5,900,000, and get the actual answer rather than 9.38, and then decide, okay, what is the difference between the actual answer and my estimate, and then use a formula to work out the percentage error. So we need to do a bit of work before we can actually work out the percentage error. And the correct answer is 8.64%. So the difference between those is going to be the error, and we want the percentage error. So percentage error is your error divided by the actual amount. And again, if we want a percentage error, we times that answer by 100. So my error is the difference between 9.38 and 8.64. The actual answer is 8.64, and that calculation I'll be timesing it by 100. And the eventual solution is 8.56%. So what does that mean? That 8.64 is the actual answer, how much the population has actually grown by. So not 9.38, but 8.64. And then how wrong is this original amount that we worked out in part 1? How wrong is that compared to the actual answer? Well, this is away from the actual answer. It's away from that by a factor of 8.56%. So this is 8.56% more than the actual answer. That's the idea of what the percentage error means here. Moving on to part C, we have a question on basically exchange rates. So what's the key information we have here? Well, we have $2,500, and we know that 3.4962 of those Brazilian dollars is equal to a euro. We then have also the added complication of a 2.5% commission. So whatever is exchanged, 2.5 of it is going to stay with the bank, and Teresa gets the remainder. So I have $2,500, and if we know that 3.4962 dollars is $1, so all we have to do is say, well, of this 2,500, how many times does 3.4962 go into that? That'll give me how many euros there are. So if I divide that 2,500 by the exchange rate, so 715 euros and 6 cents basically is how much the $2,500 actually is equal to, but we have the commission, so basically we're being charged. We get that much. We need that much money to get us $2,500, but I need to also pay the bank. So we need to work out what 2.5% of that is. So 2.5% of 715 and 6 cents works out as 17 euros and 87 cents, or a little bit more than that. So my final cost is going to be those two values added together. and we're left with an answer. When we round our answer, we get 732 and 94 cents. This question is interesting in the fact that it's not its sort of standard wording. The commission in this instance is an additional cost to Teresa, so that's why we're adding it on. Okay, often when we deal with commissions, we say we've got a certain number of dollars and we're going to convert it into euros, but before they give those amount of euros, they take a cut of a commission. But here, the commission is an additional cost, so that's why we're adding it on.